Most of the code that you write is not in the code that you create, but it is in the components that you are using, in the packages you download from a package manager for your technology and operating system and so on. And because of this, this leads to the possibility of vulnerabilities being introduced in the supply chain, either by actors that want to introduce these vulnerabilities, by malicious actors, or just because the vulnerability exists, it will end up in your product, whether you want it or not. How do you deal with this? Chances are, if you are in a large organization, there's a whole department dealing, making sure that you get the right packages and that the packages that you get are secure and so on. But what do you do if you are not in a large company and you don't have this department? Or if you're just interested in knowing what to do, how to apply these techniques? Well, in this video, we'll look at a few tools that help you deal with these types of issues. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I want to show you a quick demo of doing what's called the software bill of materials. And the software bill of materials, I'm going to use this Git repository that I created. Well, we have a few commands that we can run. And basically what we are trying to do is to run on a package, on a Docker image. We're going to run two commands. We'll see there are three, but one is just for formatting. The first one is sift. Sift with the Y just looks at the Docker image and lists all the packages that are included in the Docker image. This allows you to have a full list, like an ingredient list for your product. This is kind of like a nutritional label for software, right? How you read the ingredients for anything that you buy in a supermarket, you can read the list of packages included in a component in a Docker image. We are just going to make a demo using the Docker image, but there are similar techniques for specific packages like NPM or Python or whatever you are using. And this little setup that I made here is just taking the Docker image of this tool of Sift and running it and giving you first the software bill of materials. Second, we are going to run Gripe. Gripe is a tool that adds to the software bill of materials information about known vulnerabilities. And this is really handy because you can actually look at what is included in your Docker image and see what vulnerabilities apply. And it's a two-step process because the way you would use it is first run sift on your Docker image, but then on the same software bill of materials, you can run periodically Gripe in order to get the latest vulnerabilities that apply for your packages. And this allows you to see always what the issues are for your own product. And this is really great. It's great that we have these tools that allow us to scan and automate this process, which otherwise would be extremely complicated. Now, let's just run Gripe. Let's just run sift first. I have here a just file. Just files are similar with make files. They allow us to save commands that we don't want to remember and to make a setup that is self-contained. This is what I use them for, is basically a task runner. Really great. The first thing that you may notice here is that I'm using the best practice for getting the container, which is whenever you use a container from the internet, what you should do is to identify it by its hash, SHA 256 hash. because if you're using the tag can be changed. So for the same tag, you can have a different image. But this leads to possibilities for supply chain attacks. So what you should do is, whenever you do pull packages, just make sure they have the right hash and get them by hash. We discussed this at length in our video on supply chain attacks. So first, this is installing some stuff. I already have installed the Docker images to run sift and gripe. And then we'll just run the create SBOM target, which creates for us the software bill of materials. We're going to let it run for a little bit. What it's doing is downloading first Docker image for Python 3.9. You can replace it with whatever image you are using, it doesn't matter. Or you can use a local image, again, it doesn't matter. It works either way. And what we get is a JSON file, which we can open sbom-python 39.json. And unfortunately, this file is pretty ugly. I mean, it shows a bunch of stuff. It has components, and then it has dependencies. And you have components that you can see. It's a good file for passing to other tools, but it's not really the best file to look at. We can also open it into a visualization tool, which is called Sunshine. So I'm going to open this here. It will take a little bit. The format of this JSON file is called CycloneDX. CycloneDX is a standard for interoperability between tools using these types of showing the software bill of materials. You can also download CycloneDX viewer locally, the Sunshine viewer. Okay, so now we can look at components, and as you can see, we have how many components? 22,126 components for the Python 3.9 image. Some of these components are just system packages, but other components can be Python packages or whatever. So a few of these that I can see here are util Linux, UE-dev, wget, wheel, x11-common, x11 proto-dev, xorg-sgml-doc tools, and so on. So it's basically, it doesn't do anything fancy, just lists all the components that form your package, the list of ingredients. Well, a lot of things, right? So you're just getting Python and you get all that. Now, this is just the first step, is creating the software bill of materials. Now let's look at add CVEs target, which will run the same thing. It will run on the same file. We'll add information about CVEs, about vulnerabilities. This is using gripe, and it enhances the JSON file that we just saw with information about CVEs. Now again, this is a format that's useful to see for interconnectivity, interoperability between tools. This is a file that you can submit, for example, to a regulatory commission. If you're working in a regulated environment, you need to create these software bills of materials and show them, submit them somewhere. Again, we can open this in Firefox, and we see that now we also have a section called Vulnerabilities, and it gives us a bunch of vulnerabilities. It seems that we have around 1,234 vulnerabilities. for this package. Now, granted, this is slightly an older version of Python, and we'll see in a moment that these are not all vulnerabilities that affect us, but it's useful to know that they exist. How can we see, though, this information a little bit nicer? Well, there are a few ways. You can run a gripe to show you a table, and this is what we'll do, but also you can add, I implemented a very small Python tool that just takes the information that gripe is adding and formatting a nice report that we'll look at in a moment. But first we're gonna see the table. So SBOM, it will be out, SBOM Python 3.9 vulnerabilities.txt. This is a pretty nice one. It shows you just a text file with the list of components, the level of vulnerability, and the corresponding CVE, which if you search for will give you the exact description. But I didn't want to, I found that this is not enough, and so we created a small report using a Python tool. And it doesn't look much, it's not supposed to look much, but it gives us a little bit more context. It tells us we have 41 critical vulnerabilities, 156 high, 298 medium, 53 low, 683 none category, and 4 unknown. And now if I go to, let's say, pick one that is critical, maybe this one. I also have a link here towards a website, cvedetails.com, and I can just click on it or go to sneak, security.sneak.io. These are two websites that show information about vulnerabilities. So in this case, if I'm looking here, I have CV 2025-15467. It's critical issue summary parsing CMS auth envelope data message with maliciously crafted AEAD parameter can trigger a stack buffer overflow, and so on. So there are a bunch of information, but now if you go to the link, you can see more information about this vulnerability, what is affected, what's not affected, and various links. So it gives you a lot more information. Now let's see one that's perhaps more or easier to understand. Vulnerability CV-2018-6952. So this is an older one from 2018. A double free exists in the another hung function in pch.c in GNU patch through 2.7.6. And this is a memory corruption vulnerability. The product calls free twice on the same memory address. And apparently it was patched later on. So as you can see, you can get a nice report and look at what's going on in your dependencies and how bad is it? Do you need to fix anything? Do you need to prevent any of those? By the way, if there's a vulnerability here, it doesn't mean that you have to do something. Some of these vulnerabilities will not affect your product at all because you're not using that specific feature. Other vulnerabilities will just be very low probability or low impact, like maybe somebody can send an image or replace a file or something like that, but nothing that affects, they cannot extract things from your system. So it doesn't mean that just because we have so many vulnerabilities that we actually need to do something about those. We have 1235 vulnerabilities. But it's good to know that they are here. It's good to take a look and see what they are about and what do you need to do. particularly if you are interested in security, as you should these days, and if you're working in some kind of regulated environment, you absolutely need to do this. So I think there were a few interesting ones, but I also want to show you the difference between CVE details and SNCC. Let's take this, for example, CVE 2025-69420. This is a more recent one. It's in libssl-dev. A type confusion vulnerability exists in the timestamp response verification code where an ASN1_type union member is accessed without first validating the type, causing an invalid or null pointer dereference when processing a malformed timestamp response file. So this doesn't verify a potential null, which can lead to null reference exception or null pointer dereference. If we go to cvedetails.com, we find kind of the same thing. It says a few more information about what's going on. The timestamp protocol is not widely used, and the impact of the exploit is just a denial of service. So this is what we can do. I like how they say just a denial of service. If you go to SNCC, the link is actually a search, and let's go to, I don't know, the first one. We get the same description more or less, but then we have some reference links, and it also gives you some more information about how this can be used. So attack vector network, attack complexity low, privileges require none, user interaction none, scope unchanged, confidentiality none, integrity none, availability low. So what this means is that this issue can actually create, as they said, a denial of service attack, but you can see it in a nice table. And they have information for SUSE and Red Hat, and for Red Hat it's a higher risk on availability, presumably because of other components that they are using. So let's look at another one. I noted one which is from 2007. Let's see if we can find it. There is even one from 2003. Okay, 2007-3996. Multiple integer overflows in libgd in PHP before 5.2.4 allow remote attackers to call a denial of service, application crash, and possibly execute arbitrary code via large srcw or srch value to the GD image copy resize function, or large si height or for sx width value to the GD image create or the GD image create through color function. And now the question is, why do we care about PHP when we're talking about Python? Well, this was a vulnerability that was first discovered in PHP, but it actually turned out that it had a connection with a library, with libgd, but the description is still related to PHP. And if we look at this, this is a medium one, numeric errors, and there are small risks of confidentiality, integrity, and availability, but it requires user interaction. So this is why it's less risk. So as you can see, you get a lot of vulnerabilities here. Now the thing that is not that simple here is the score for CVE, the severity, is not really particular to your implementation. You can use different scores for your particular product, which means you'll need to go through some of these vulnerabilities and adjust their severity in the particular case of your product. All right, so what have we learned? We have learned that we need to do software bill of materials. I think it's a must. All organizations on security recommend it, OWASP recommends it. It's something that we need to do. NIST DOI recommends it. Current and future regulations will likely ask for it more and more and more. Good news is we already have tools that can create this for us. We have tools that can scan this and add vulnerability data. We can include these tools in our continuous integration and generate nice reports and compare past with current so that we see if there are any new vulnerabilities that came up for the packages that we need. You can see the real systems. Of course, for real systems, we'll have multiple images and then we'll need to scan multiple ones. For example, if you have WordPress, you'll probably have one for WordPress, one for the database, one for the PHP stack or LAMP stack that you're using. You need to scan each of these independently. So depending on how many images you produce, you need as many scans. And you can have one vulnerability that affects multiple components across the stacks. The good news is it's pretty easy to set up, as I've showed you. It's not a big deal. The bad news is you have a lot of work to do to filter out and to prioritize those vulnerabilities that make sense for you and to include them in your threat model, which is where I think I invite you to join our secure coding and cybersecurity learning programs, because that's where we practice threat modeling. And it's a skill that will be more and more required from each one of us as software development advances. This is it from me today. Do you want to learn anything else? Let me know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.